Lesson 3 of our redox reactions. In this lesson we're going to learn how to balance more complex half equations than we've been doing earlier. More complex ions can form than we've been looking at lately, and these are called polyatomic ions. They have more than one element involved. For example, manganese ions can also have oxygen added, forming the permanganate ion. Something to remember with permanganate is permanganate starts with P, and the permanganate ion, which is this one here, is purple, whereas Mn2+ is colourless. So in a reaction where this iron's involved, you might start with permanganate, so the solution would be purple, and then when it has undergone its redox reaction, the solution will turn colourless because the manganese ion is colourless. So as part of our assessment we will be discussing the observations as well. So in order to write a half equation for this, there are 4 steps that you need to follow, and they have to be in the right order. So how we're going to remember this order is an important memory jog that I want you to think about in a visual way. It tends to stick better if you see these images. So firstly, the number key is 1 sun, 2 shoe, 3 tree, 4 door. Okay, so you'll notice that those words rhyme with the number. So 1 sun, 2 shoe, 3 tree, 4 door. Okay, so those words are going to make you know which step you're on. And then what you're going to do for step 1, sun, is balance all the atoms that are not oxygen and hydrogen. So for this one, it would help to say picture a sun, and then in your mind, so you need to look up and picture the sun, and the sun is balancing, and you've got O and an H on this sort of seesaw balancing thing crossed out. So that's sort of a picture that you're imagining, which is going to remind you that to start with you're going to balance everything that's not oxygen and not hydrogen. For the second one, shoe, 2 shoe, you've got to look at both sides of the arrow, and when there's more oxygens on one side than the other, we have to balance the oxygens by adding water. So you want to imagine a shoe for this one, so picture a shoe, and in the shoe we're dropping some water. So you see a shoe filling up with water. Okay, so you can do that in your mind, picture a shoe and see it filling up with water. That should make that second step stick. So as soon as you see a shoe, you're going to know you're talking about step 2 and that you're adding water in this step. Number 3, you've got to balance hydrogens. So any hydrogens on one side, you've got to have the same amount of hydrogens on the other side. And how we're going to balance those hydrogens is simply by adding H+ ions. So for 3 tree, you're going to picture a tree, and hanging up in the tree you're going to see lots of H+. They have to be H+, they have to be hydrogen ions. And then finally, the 4th step is 4 door. So you want to picture a door, and you're adding electrons to the most positive side. So if the positive side's that side, you're going to add electrons to it. Okay, so that's how you balance a half equation that's more complex and entails more than one element. After you've balanced that half equation, then you will add the two half equations of the redox equations, just like we've done before, by first making sure that there are an equal number of electrons on both sides. So here's an example of balancing this manganese half equation that we looked at on the other page. So we're starting off with Mn2 plus, and we're going to MnO4 minus. Now it's important when you look at an ion like this, MnO4 minus, that you understand that the charge here is only a 1 minus charge. The 4 here is referring to the oxygens. When that number's down the bottom, it's referring to how many oxygens there are. So there's 4 oxygens in this polyatomic ion, and there's a 1 minus charge on it. Something like sulfate, for example, may be like this. So there's a 2 minus charge, and there are 4 oxygens in this polyatomic ion. Okay, so first step, one sun. Remember, you're picturing a sun, and you're saying that we're balancing anything that's not hydrogen and oxygen. So on this side, the only element that there is Mn, manganese, and there's one of them. On this side, there's only one of them also. So step 1, nothing changes. Step 2, we remember now we're looking for oxygens. So maybe if you picture with your shoe an O on the side of the shoe, because that's what you're looking for. You're looking for oxygens, and we see that we've got 4 oxygens on this side, so that means I have to add 4 waters to the other side to balance those oxygens. So that's what happens in step 2, we're adding water. Remember to shoe water. Third step, now because we've added water, we added hydrogens into this equation, and because there's a 4 in front of the water, that means we've got 4 times 2 hydrogens. So all up we've got 8 hydrogens on the left because of those 4 waters. So that's why we have to add 8 H pluses on the other side. Finally, for door, we have to look at balancing the charge by adding electrons to the most positive side, just like we did with the more simple half equations. So this can be quite complicated, and you really have to pay attention to all the ionic charges. So on this left of the arrow, we've got 2 plus total charge. Water's neutral, it hasn't got a charge, but the manganese ion had a 2 plus charge. Whereas on this side, I've got 1 minus for the permanganate ion and 8 pluses for the hydrogen ions. So together that makes 7 plus. So on the left we've got 2 plus, on the right we've got 7 plus. So we have to add electrons to the most positive side, which is the right, because 7 plus is more positive than 2 plus. And we have to add enough to make it equal the left side. So what do I have to add to 7 plus to make it equal 2 plus? I have to add 5 electrons, which are minus, remember. Okay, so that's why we've added 5 electrons in that final step. So now you've balanced that half equation, you've done the 4 steps. So in your workbook, here are all the complex half equations that you will need to do for this assessment. So you can have a go with them. As I'll be discussing on the next slide, hydrogen peroxide, which is this species here, can go to water and it can go to oxygen. What you would notice when this would happen would be that you would get bubbles with this one, and you wouldn't get any bubbles with this one. Good luck with that.